Hello guys, welcome to my channel, Nexus. Today we are starting an essential topic in mathematics called differential equations. Now we'll start with the definition of a differential equation. What is it? A differential equation is an equation which involves the derivatives of a dependent variable with respect to one or more independent variables. So the key word here is that it involves derivatives of a dependent variable with respect to one or more independent variable. Now, in some books, we write unknown function in place of the independent variable. That is what they do. So, unknown function. So, that is it. So, we have the differential equation. Now, let's take an example of a differential equation. So, we'll take an example. So, an example of a differential equation. So we have our first example we take is, so our first example, we have y prime prime plus y equal to e raised to the power x. Now looking at this one, what is our dependent variable? Because we want to see whether it's a differential equation. So our dependent variable is y, and our independent variable here is x in our case here. So y and then x. Now if you don't have you don't know how to get that, you can rewrite this one in terms of the variables given to you. So you can write it as d squared y over d x squared plus y equal to e raised to the power x. In that case, we can see that okay, the dependent variable is here and then the independent variable is here. Now let's take example 2, where we say we have this over that all to the power 2 plus 2 brackets d squared s over d t squared all to the power 5 plus the s over the t bracket open and closed 2 equal to 0. Now in this case, we can see that we have a derivative. The dependent variable here will be what? So the dependent variable is s, you guess right, and then the independent variable is t. Good. So we have t, we have s as our independent variable. So here there's a derivative. Please, that is the first requirement. It involves a derivative. So there's a derivative here. We have another derivative here. We have another derivative here. This also shows that a differential equation can be made up of only derivatives of the variables, not maybe you will not see any variable there. So you take note of that one too. And last example here, then we move on. So we can also talk about example 3. So we say partial squared b over partial x squared plus partial squared b partial y squared plus partial squared b over partial z squared equal to 0. Now, with this example that we have here, we can see that when we have this here, we have our dependent variable. And what is our dependent variable? We can see v, and then independent, we have, in the first derivative we can see x there, in the second derivative we can see y here, And in the third derivative, we can see z here. So we are saying it is with respect to one or more independent variables. So you can see that we have one or more independent variable here. So we have one dependent variable and then more than one independent variable. So you take notes. All right, so we move on to the types of differential equation. Now, there are two types of differential equation, and the definition is solely based on the type of the number of dependent or independent variables that are available. So the number of independent variables that are available determines the type of equation it will be. So we have the first one we are going to discuss. You say ordinary differential equation, which in other words we always say ODE. ODE. This is a type of differential equation which involves the derivatives with respect to a single independent variable. The key word here, a single independent variable. That's only one independent variable is available here. And so if we have only one independent variable, then we can classify that as an ordinary differential equation. So let's take an example. So we have an example. So we have the squared y over the x squared plus y equal to ex. So this is our first example we have. Now looking at this one, how many independent variables do we have here? We have one. So the independent variable is 1. So we have 1. And then that is only x. So let me write that. And then we have the dependent variable. The dependent variable. And how many do we have here? We have 1. Y. But that doesn't, the definition doesn't depend on the dependent variable. It depends on this one, which is the independent variable. Let's take another one. So we have this. Okay, so we have this one. So with this one, we have two derivatives here. But looking at the derivatives, we can see that we have this one, t appearing here, and then t appearing here, which are the independent variables. They are many. They are only 1. So they are only 1. So we have only one independent variable here, which is what? C. Hence, this is an ODE. So you take note. Now, the second type of differential equation is the partial differential equation. We have the partial differential equation. Now, the partial differential equation, what is it? This is a type of differential equation in which the derivatives with respect to two or more independent variables. So the derivatives or the independent variables are more than 1. So the opposite of ordinary differential equation. An example is, so example I can give here is, with the first one I gave, partial v over partial x squared plus partial squared v over partial y squared plus partial squared v over partial z squared equal to 0. Now here the dependent variable, how many are they? You said 1, and that is correct. So we have only v. Then the independent variable. So the independent variable, how many do we have? We have x, we have y, we have z. We have 3. So that is more than 1. And so this is a very nice example for partial differential equation. So that is that. All right, so we continue with order of differential equation. Now, when we talk about order of differential equation, we are saying that It is the highest derivative which is present in the equation. The highest derivative which is present in the equation. What does it mean? We mean that if you have a differential equation, let's say you have partial this partial over partial x to the power 4 plus partial squared z over partial x partial y all to the power 6 equal to x. Now, when we have this, and then we are being asked for the order, looking at this one, we can see that here we've differentiated this one how many times? 4 times. And then here, the differentiation has been done how many times? 2 times. Now, when you look at them, which one of them is the highest? The highest one, which is the differentiation that is done how many times? 4 times, is the order of the differential equation. It determines the order. So here, the order of this differential equation is what? Is 4. Now, let's take another example. So we have this. Equal to e raised to the power x. So this is example 1, example 2. Now with this example 2, we are saying that what is the order of this differential equation? You can see that we have the derivative here, and then with the derivative, it's differentiated how many times? Twice. Apart from that, there's no other derivative. So here, the order of this differential equation is what? Is 2. So you take note. The order is the highest derivative which appears in the equation. So if you forget, in court, who is the highest? Is the judge. So the highest here is the order. The highest here is the order. Who gives the order of the differential equation? Now let's move on to the degree of a differential equation. Degree of a differential equation. Now, after finding the order of a differential equation, then there's sentence. So the sentence here, or the exponent that we are going to give to the person, is what we call the degree of the differential equation. So the degree refers to the highest, or the exponent of the highest order. The exponent of the highest order. So let's move on. So example is that, let's say we have been given this. We have been given this one. So we have this. Okay. So now, first we have to find the order. So what is the order of this differential equation? Now let's see. So here, how many times is it differentiated? We are not looking at what is outside, but we are looking at the derivative here. And it is differentiated how many times? Once. So we are checking in between the d's here. So if you check here, the number there will determine the differential. So here it is once, here it is twice, and here it's 4 times. So automatically, what the definition said, the highest of the derivative. So that is 4. So the order is 4, or we can say 4th order. Now, we also talk about the degree. So the degree is the order of the highest derivative, the exponent of the highest derivative. Sorry. So the exponent is what? 2. So the degree is what? 2. But also note something here. It's not all differential equation that has a degree. If the differential equation is found in transcendental functions such as log and then trigonometric functions, then if the dependent variable is found inside any of these equations, in any of these functions, then it doesn't have a degree. So example is when I state this one, which is we have y prime prime plus y prime all squared equal to ln y prime prime. Now looking at this one, the dependent variable y is contained in a log function, the natural log this here. So in that case, this one has no what degree. This one has no degree. Another one, another example which I will also want to draw your attention is we don't have a fraction degree of a differential equation. So you don't have, it is not fractional, and then the degree does not involve a radical. It cannot be a root. So in simply put, it can never be a root. So example, if they give it to you, you try to rationalize the root, and then if there's a fraction somewhere, you have to try to make it a whole number. So example is y prime prime all to the power 2 over 3 equal to 1 minus y prime. Now in this case, we can see that fine, we have this, so we can rewrite this one as the cubic root of y prime prime equal to 1 minus y prime, and then we take the cube of both sides, so 3 then we have y prime prime equal to 1 minus y prime all to the power 3. Now here, please, my square got missing here. Let me bring it, and then let me bring it here. So if it is here now, what is the power or the exponent of the highest order? And that is 2. So the degree is 2. All right. So that is that for that one. All right. So the last thing we'll talk about in this lesson is the solution of a differential equation. Now, when we talk about a solution of a differential equation, we say a solution of a differential equation is any function. It's any function. It can be any function. It's any function which is free of derivatives. So there is no derivative. So if you find the answer, your answer should be free of derivatives, and which satisfies, please, the end is very important. End. It doesn't mean if it is free of derivative and it doesn't satisfy the differential equation, you are free. No. It is free of derivatives and satisfy identically the differential equation. That means that it should satisfy the differential equation. Just as when you are in an algebra class, you just take, they give you 2x plus 4 equal to 0. Then you find x to be equal to -2. When you substitute, the left hand side will be equal to the right hand side. The same way, when you find a solution, the left hand side should be equal to the right hand side. So in simply put, we are saying that we have the dependent variable. So in our case, let's say we have y, then we have a function phi of the independent variable, which is what? X. We didn't say we have a derivative of the function. No. We say we have a function which is free of derivative, and this function satisfies the equation. So let's take an example and see if truly we have a solution, it will satisfy an equation. So is y of x equal to c1 sine 2x plus c2 cos 2x, where c1 and c2 are constants. A solution of the differential equation y prime prime plus 4y equal to 0. So how do we testify or test that this solution is satisfy this differential equation? So first, we look at the differential equation given to you. Now y is differentiated twice. Now we have y here, so that means that we will differentiate this y how many times? 2 times, and then we have y, just y, so we just can substitute this one here, and then we'll be free. So we differentiate y, that's the only work we do here. So differentiate y twice. So first derivative, when we differentiate sine 2x, we'll get 2. Now we have c1, and when you differentiate the whole function, you're going to get cos 2x, and then when you differentiate cos, you're going to get negative, so we have negative, and then when you differentiate what is inside, you get 2 c2 sine 2x. Then we differentiate it twice, so y prime prime is equal to, now when you differentiate this one, same procedure here, cos, when you differentiate you get negative sign, so we get negative 4 c1 sine 2x minus 4c2 cos 2x. So that is that for the derivatives. Now we substitute into the d, so sub into the de to verify. So we sub, then we have negative 4 c1 sine 2x minus 4 c2 cos 2x plus, now 4, what is our y? c1 sine 2x plus c2 cos 2x. Now when we expand the equation, what are we going to have? We are going to have negative 4 c1 sine 2x minus 4 c2 cos 2x plus 4 c1 sine 2x plus 4 c2 cos 2x. Now we can see that we have identical terms here. Negative 4 c1 sine 2x, 4 c1 sine 2x, they can take out each other. So this one will take this one, and then this one will also take this one, giving us what? 0. And then that is the left hand side, which is equal to 0, the right hand side. Thus, y of x equal to c1 sine 2x plus c2 cos 2x is a solution. So in our endeavor to find solutions to differential equations, please take notes. Our solutions must satisfy the equation. If it doesn't satisfy, then we are not doing something right. Alright, so if you find this video helpful, please leave a like, subscribe, and then share to your friends so that they also come to know the truth. Bye bye.